Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is integration. We are going to learn a technique of finding integral of some special functions, and one of the techniques we are going to learn today is integration by parts. So let's begin. After completing the very lesson today, my dear student, will be able to use the integration by parts as a technique to find the integral of some very special functions. This is what I hope you'll be able to do after completing the very lesson today. So, my dear student, as usually the favorite segment of the lesson today, I will give you another interesting number. This number is 13. 13 is so special, so interesting. In fact, it has a lot of interesting properties. We see just one out of those interesting properties of this number 13 in this very lesson, and that will be done after completing my lesson today. So don't go away. To begin the lesson, my dear student, let us just consider these two special functions. Number one function, suppose you wanted to find the integral of 2x e raised to x with respect to x. This is a very special function. Another special function that we wanted to find it is integral is x sine x dx. These two type of functions, the normal formula for finding integral of functions may not work alone in these types of functions. So in that case, we have to employ another special techniques, and it is this techniques that we are going to learn in this very lesson, that is integration by parts. So integration by parts is the one that we're going to work best on these types of functions. So let us see the rule for this integration by parts. The rule says if you have the function y, which is a function of x, and this right hand side of the function y can be rewritten as f of x equals to uv, where u and b are both the functions of x. That is, y can now be rewritten as uv, where u and b are both the functions of x. That is, y is a product of two other functions. Then if you ask to find the integral of that kind of function y, which is now product of two other functions u and v, just like in these two special cases, you can see 2x can be one function, e raised to x is another function, and the two functions are now multiplied together. Similarly, in the second one, this x alone can be one function, and the sine x can be another function, and which we are multiplying the two functions together. So this is a product of two functions. This also is a product of two functions. So this type of functions, if we are to find their integral, it is this technique, that integration by parts, that you are going to apply. So it says integral of uv, where u and b are both functions of x. So in short, integral of a function that can be expressed as product of two other functions. This, the rule says, is nothing but u multiplied by the integral of v dx minus integral with respect to x of what is in this bracket, and what is in the bracket is another integral of v with respect to x, then multiplied by du dx. This is the formula, or this is the rule that we are going to make use of to find the integral of these types of function, and it is this rule that we called integration by parts. We are going to take examples how we can make use of this. I believe is somehow trickish, but when we take examples, you are going to get it very, very better, I believe. So let's just move and take examples. Example number one, the question says find the integral of 2x e raised to x dx. Solution to this very problem. Looking at this function critically, I can see that 2x can be one function, and e raised to x can be another function. So in short, the entire function can be product of two other functions. That makes me think that I can now employ this integration by parts to find the integral of these functions. So what I'm going to do first is to write down the formula for integration by parts, because it's somehow trickish. So it says integral of uv dx, that is integral of product of two other functions, and both functions of x with respect to x is nothing but u, that is the very first function, multiplied by the integral of the second function v with respect to x. then minus integral of or integral with respect to x of inside the bracket is integral of the second function v with respect to x, then multiplied by du dx. This is the formula. So I can now find this integral. Let me just write it. Integral of 2x e raised to x dx. So what I'm going to do first now is to let one of the functions to be my u, then the other one to be v. Let me do that. So let u be equals to this very first function 2x. 2x. I have 2x as my u. Then the other part will now be your function v. That is v will now be equals to e raised to x. Then what will now happen? You now find du dx because I need du dx in this very formula. So you now find the derivative of the function u with respect to x. There you now have du dx to be equals to 2. This is the derivative of the function u. Then you now go back to this very formula and substitute u, v, and du dx. So let me just move. If start with the very first part, u multiplied by integral v dx, I'm going to have 2x multiplied by the integral e raised to x dx. The 2x is your u, look at it here, and the e raised to x is your v, look at it here, then dx minus, then I'll move to the second part, which says integral with respect to x of v with respect to x, then multiply by du dx. So there we now have integral with respect to x of inside the bracket is integral of e raised to x dx. E raised to x is your v. Look at it. Then multiplied by du dx, which I have here as my 2. So I'll continue. So what I'm going to do now is to find this integral and this integral inside the bracket. So let me find this integral. Integral of exponential function. Remember, the coefficient of x will now be 1 over that coefficient, then multiply by the exponential function. So I'm going to have integral of e raised to x here is nothing but e raised to x because the coefficient here is 1. So 1 over 1 times e raised to x is giving you e raised to x. Then times this 2x, it will now give you 2x e raised to x. Then minus this integration inside this very bracket, e raised to x, it is integral, is e raised to x. Then times this 2, it gives you 2 e raised to x, then dx. This dx is the dx I have outside. Then I'm now doing this integration. Is what I'm going to do next. So copying my 2x e raised to x, and the integral of e raised to x is another e raised to x times this 2 gives you minus 2 e raised to x, then plus the constant of integration. And this is now the integral of this very function. And let me just move to take another example. Example number 2, we asked to find the integral of x sine x dx. Solution to this very problem. Looking at the function again, x can be one function and the sine x can be another function, which means this function is a product of two other functions. So finding integral is now integration by parts that I'm going to use as a technique of finding this type of function. So let me just write my integration formula. That is integration by parts. It says integral of uv dx is equals to u multiplied by integral of v dx, then minus integral with respect to x of the bracket inside the bracket is integral of v dx, then multiply by du dx. Now let my x, the very first part here, to be my u. So let u be x. Then the second part, that is sine x, will now be your v. So I have my v to be equals to sine x. So I'll now find the du dx because I have du dx in this very formula. So I need to find this du dx, that is derivative of the function u with respect to x. There du dx, it will now be derivative of x, it is now going to be 1. So having 1 as derivative of x, then I'll go back to this very formula and substitute u, v, and du dx. So let me move. So in attempt to find the integral of x sine x, that is integral of x sine x. I will now make use of this very formula, and I will now substitute. So I'm going to have my u, which is x, and my v, which is sine x. So this part will now be x integral sine x dx minus. So I'll now substitute this very part. I have my v, which is sine x, and I have my du dx, which is this one. So substituting this part here, I'm going to have integral with respect to x of inside the bracket is integral sine x dx multiplied by 1. 1 is your du dx, look at it here, and your v is sine x. So I'll continue. So I'll now find the integral of this very part, that is integral of sine x, and that integral sine x multiplied by this x. Integral sine x, remember, is now minus cos x. So times this x that is outside the integral sign, minus. So I'm now starting with the integration inside this very bracket. That is integral of sine x with respect to x. So I'm going to have minus cos x, then dx. This dx is the outer dx here. So I'll continue. So I'm now going to multiply. X times minus cos x gives me minus x cos x, and this minus times this integration. That is the integral of minus cos x. It will give you minus sine x, and that minus x times the minus outside, so it will now change to plus sine x, then plus the constant of the integration c. This is now the integral of this very function x sine x with respect to x. With these few examples, I hope you'll be able to find the integral of those special functions that you applied integration by parts as a techniques to find those integral. Thank you for your attention, and let me just move to the last segment. Tomorrow is fun, and explain what is interested about the number 13. So it says 13 is a prime number, and this, if you take it a square, if you take the square of 13, what you now have, that very result, if you turn it upside down, it will produce another prime number. So let's find out what is 13 square. 13 square means 13 times another 13, and that will give you answer 169. But what this property is telling, which I believe you never noticed, if you are to turn this very number upside down, let me just turn it and see what you are going to have. This is 169 again, but let me turn it again. So if I turn it like this, it gives you 691. This is 691, and this number is prime. And this number is just obtained from 13 square, but that result when turned upside down. So this is a prime number, which I believe you never mind to do this. So we see more of this amazing things in mathematics in our subsequent lesson.